During this lesson you will be required to fill out a worksheet. I recommend you read through the worksheet before viewing the lesson. In order to give you time to do this, you can use the pause button at the bottom of the screen. Learning outcomes. By the end of this lesson, you should be able to describe the procedure for laying a length of drain, state what an invert level is, describe one method that could be used for setting out and laying a length of drain at a gradient of 1 in 60, and use a sketch to illustrate your answer. You should also be able to list 3 tests used to check drainage systems. The procedure for laying a length of drain. 1. Side rails are set up to the required gradient. The trench is excavated to the correct fall by using a boning rod or a traveller. So the fall at the bottom of the trench is kept parallel to the line of sight using the boning rod. The drain bed is laid 10mm single size or 14 to 15mm graded bedding material, so for example pebbles. So it's excavated and the bedding layer is laid. 4. The drain can be laid ensuring the inverts are correctly aligned. We can see from the diagram opposite that the invert level is the bottom inside of the pipe. 5. Testing the drains can now be done using various methods, for example the smoke test, the air test, the water test, or the ball or Mandrel test. 6. Haunching can be done by surrounding the pipe with a dry concrete mix or small stone to protect the pipe. Trench is excavated, pipe is laid, and then the haunching is surrounds the pipe in order to protect the pipe and prevent it from moving. 7. The drain can now be backfilled carefully with no large stones. Here's a simple method of setting out a fall of 1 in 40. The formula we use is the distance divided by the gradient equals the fall. So for example, if we had a distance of 4 meters and the gradient was 1 in 40, so we take 4 meters divided it by 40 gives us 0.1 of a meter or 100 millimeters. So if we take a straight edge 4 meters long and cut it into a taper, so we have 50 millimeters width on one end going down to 150 millimeters on the other end, so the difference is 100 millimeters. Then by simply placing a spirit level on top of the straight edge, we can tap in our pegs down to the required fall, and this would give us a fall of 1 in 40 over a distance of 4 meters. The air test. This here is a photograph of a manometer. So what we do is, you can see we have a rubber stopper. So the rubber stopper is placed in the end of the drain, which the manometer is attached to. So these rubber stoppers are placed into the drain, and there's a wing nut on top of the rubber stopper. So by twisting the wing nut, it compresses the rubber stopper between 2 metal plates, and the rubber stopper expands, blocking the entire end of the pipe. This gives us a nice seal for pumping the air into the system. Now, any other open ends of the drain also have to have these stoppers placed in them in order to seal up the drain. So the procedures. One, after attaching the manometer to the end of the pipeline, the manometer has water in it, so using the hand pump, we pump air into the drainage system until the pressure on the manometer reads between 100 and 120 millimeters. We leave that for 5 to 10 minutes just to settle. Then using the control valve, we reduce the pressure down to 100 millimeters. We leave this for a further 5 minutes, and the pressure should not drop below 75 millimeters. If it does drop below 75 millimeters, then the system has failed the test. Next here we have the water test. So again, all open ends of the drain have to be blocked up using the rubber stoppers. And then on the head of the drain, or the highest end of the drain, we have to place an uprighted pipe. This upright pipe is going to allow us to fill the system up with water. So the procedure: we fill the system with water and we leave it for 120 minutes to allow for displacement. So we leave it for 2 hours. You can see in the diagram opposite there, we have the upright is lashed to a timber brace in order to stabilise it while we're filling the system with water. We need to monitor this then for a further 30 minutes, topping up the water as we go. And we want to keep a record of the quantity of water added to the system over this 30-minute period. So the procedure: using the table opposite, we read the figure given for the maximum acceptable loss for the diameter of pipe, and we multiply that by the length of the pipeline being tested. The measured quantity must be less than that calculated quantity for the pipeline to pass the test. So for example, if we were using a 20 metre long pipe and the diameter of the pipe was 100 millimeters, this would allow, we'd be allowed for 0.05 litres of water will be allowed to be lost for every metre run. So it's 0.05 litres of water multiplied by 20, which is the amount of metres the length of the pipe is. This is equal to 1 litre of water. So over that period of time, over that 30 minutes, you wouldn't be able to top up the system with any more than 1 litre of water. If you did have to top it up with more than 1 litre of water, then the system would fail the test. Next is the smoke test. Although testing with smoke is not an official test of water tightness, it may be used with non-PVCU pipelines to identify leaks or defects that have not made themselves apparent in air or water tests. Again, each outlet is blocked using a rubber stopper, except for the lowest outlet. Then an oily rag is lit and the smoke is allowed to enter the drain through the lowest point, where any leaks can be identified. Last then is the Mandrel Test, used on critical pipelines to verify the quality of installation. So these are really only used to verify quality of installation as opposed to whether there's any leaks in the pipeline. A ball is passed through the pipeline to ensure internal diameter is maintained. So we go to the highest point of the drain, drop the ball in, and then the ball should exit at the lowest point of the drain. PVCU pipelines can become deformed due to backfilling, so the ball used is 10 millimeters less than 95% of the pipe's internal diameter. So for example, for a 150 millimeter diameter PVCU pipeline, the mandrel would be 150 millimeters multiplied by 95% gives us 142.5 mil, minus the 10 mil gives us 132.5 mil diameter ball. Conclusion: how to lay and length the drain. Site rails are set up to the required gradient. Excavate using boning rods. Lay the drain bed using pebbles. Lay the drain ensuring inverts are correct. Then test the drain. Haunch or surround the pipe with pebbles. And then backfill carefully with no large stones. The invert level is the bottom of the pipe. A spirit level and tapered straight edge can be used for setting out a drain to the required gradient. Water, air, smoke and ball test are all used for checking drains.